today we're looking at systems of equations and matrices. What we're going to be looking at are lines and finding points of intersection in a line of lines. For instance, if you're going to draw two lines, more than likely those two lines intersect in one point. That's the most common situation. If you're going to draw two lines, they'll intersect. Would it be possible to draw two lines and they intersect in exactly 3 points? Well, no. Either the two lines are going to intersect in 1 point, or what do you call two lines that never intersect? Do y'all remember that terminology from geometry? Two lines that never intersect. Start with a P. Parallel. Parallel lines never intersect. So, if you're going to draw just two lines at random, either they'll intersect in 1 point, which is an ordered pair x, y, or if they're parallel lines, then they'll never intersect. And the third possibility, if you're going to draw two lines, and this is a rare possibility, what if you drew one line right on top of another? See, I'm drawing the red line on top of the green line. If you draw one line on top of the other, then how many points of intersection are there? Well, every point is a point of intersection. There's infinitely many points of intersection. What we're going to be looking at today is this first case here. That's the interesting case, where two lines intersect in 1 point. Okay. We're going to have several techniques for finding these points of intersection. And the first technique that we're going to use is something called substitution. Pardon me. It says, solve the following system of equations. System of equations just means 2 or 3 equations. What we want to do is find the point of intersection. Let me write this one down, and then we're going to use this method called substitution. Problem 1. 5x plus 8y equals 2. Now the second equation is x equals 30 minus 6y. Oh, it is a 9y. Darn. There. So we have 5x plus 8y equals 2, and x equals 30 minus 9y. These equations have no exponents in them. So both of these are lines, and we're trying to find the point of intersection. And you have several options. Either it's just one, there's an ordered pair as your answer, or infinitely many solutions, that would be one line on top of the other. No solution would be parallel. What's going to happen with y'all is always this, but I'll show y'all what would happen if you were going to have these other two solutions as we work through them. Okay? This method here is called substitution. And with substitution, you're going to take these two equations and write just one equation by substituting. Right here it says x equals. We could plug all of this in for that x right there. If we replace this black x with 30 minus 9y, we're going to get a linear equation that we know how to solve. That's why the name of this method is substitution. We're substituting in for x. Now, how do we go about solving this? Excuse me, we're substituting in for x. Now we're going to solve for y. Yep, distribute the 5. Did y'all hear that? 150 minus 45y plus 8y equals 2. So I distribute the 5. Then let's combine these two y terms, the negative 45 plus 8. We'd have 150. Is negative 45 plus 8, is that a negative 37? Oh, perfectly said. Let's isolate the y. We'll move that 150, which is subtract 150. So we have negative 37y equals, 2 minus 150, is that a negative 148? And then divide both sides by negative 37. And we get y equals positive, is it positive 4? 28, yes. Now, when you have two lines intersecting, your answer is an ordered pair. What we've just found is the y value. Our answer is going to look like this. 4 is the y value. Well, how the heck do we find the x value? We need to know the x. It's got to be an ordered pair x, y. Well, what's the name of this method? It's called substitution. Does that give you an idea of what we're going to do now? Substitute the 4 in for y, like right here. If we put a 4 in for y, we'd have x equals 30 minus 9 times 4. So the 9 times 4 is 36. So we have x equals 30 minus 36, negative 6. So there's our point of intersection. Negative 6, comma 4. And you can sort of check this if this were a test and you wanted to make sure you had it right by plugging this number in for x and this number for y. If I plug a negative 6 in for x and a 4 for y, am I going to get a 2? Let's see, 30 times negative 6, 5 times negative 6 is negative 30. 8 times 4 is 32. So is negative 30 plus 32, is that giving me a 2? Yeah. If I plug a negative 6 in for this x and a 4 for the y, we're definitely going to get a true statement. 30 minus 36 is negative 6. That's how we found that one. So I come over here and type in my solution. Parentheses, negative 6, comma 4, close parentheses. Make sure you get those parentheses around there. Okay? If you don't put the parentheses, it's going to count it wrong. Okay? Now, notice all of this work out here. The other two special cases, the parallel and the one line on top of the other, those occur if you have everything subtracts out. Imagine if all the variables subtracted out, if you wind up with just a statement, if everything on the left subtracts out and you're left just with a number, and on the right, all you have is a different number. So if you have number equals different number, then the answer would be the no solution. And again, you don't see any of those in this assignment, but for this one over here, if everything on the left subtracts out, all the variables and stuff are gone, and all you have is a number on the left, and then the same number on the right. Like 3 equals 3, 7 equals 7, 0 equals 0. If that happens, then it's the infinitely many points of intersection. If, on the other hand, you get something like 3 equals 5, one number equals a different number, that would be the no solution. And that's just a little extra. By that I mean the homework, I don't have any like that on it. If we go to the next problem, you'll notice with this substitution method, you sort of have to have one of the variables isolated, the way this says x equals. So you plug all of this in for the other x. The natural question to ask is, what if we don't have x equals or y equals? Let me write this one down. Problem 2. 5x plus y equals 13, and 8x minus 4y equals 4. Now, how does this problem differ from the one we just did? In the one we just did, one of the variables was also already isolated. On problem 2, there's no variable that's isolated. In order to use the substitution method, because you're going to see several methods today, in order to use the substitution method, you sort of have to be able to easily isolate one of the variables. Looking at the two equations, which one of these 4 letters would be the easiest one to get by itself?
Y.
This y right here. So with this one, first thing I would do is isolate this y by moving the 5x over. If I move the 5x over, I have y equals 13 minus 5x. Now it's very much like problem 1. You might ask yourself, well, wait a minute, what if there were a number in front of this y here and you could have isolated easily? Then you wouldn't use substitution. You would use a different method. With substitution, you have to be able to easily isolate. Like you wouldn't want to isolate this x because you'd move the y and then you'd have to divide by 5. You sure wouldn't want fractions here to be plugging in. So I isolate this y and I'm going to plug it in to the other equation. We're going from 2 equations down to just 1 equation. So we have the purple 8x minus 4, and in place of that y, I'm going to put 13 minus 5x. Now we have 8x. Distribute the minus 4. Is that going to give a minus 42?
52.
Oh yeah, 52. Where did I get 42? 52. And then what is that? A plus 20x. So let's see. 8x minus 20x would be a negative 12x. Then we have a minus 52 equals 4. And this one we can sort of isolate the x without too much trouble on. what would we do? I'm going to add 52 to both sides. So we have negative 12x equals 4 plus 52. Is that a 56? And then do what? Divide both sides by negative 12. I'm just wondering, let's see, what's 56 divided by 12? Doesn't go evenly, does it? I'm just going to look and make sure I didn't miscopy this problem. Because what did I do wrong? Uh-huh. Oh my gosh! Did y'all see what I did? Oh, how embarrassing. The 8x plus 20x, that should be a 28x. Why did I subtract them? Okay? Well, okay, then this is what we're going to do. Well, here's what I'm going to do. Okay. I'm going to make a note that next semester this video will not be the one that goes in the assignment for the online students. The 8 plus 20x is 28x. I'm sorry about that. Minus 52 equals 4. Not sure why I subtracted those. Now, I'll move the 22 over. And is that going to be still a 56? Okay, good. We're not going to wind up with a fraction here. Divide both sides by 28. What are we getting for x? Yeah. 28. Well, our answer is an ordered pair. And we've just found the x value. The x value is 2. What about the y value? What am I going to do with this 2 to get the y value? Yeah, plug it in. Theoretically, you can plug it into any equation that has x and y. I think this is the easiest one to use. The one that I've written in the form y equals 13 minus 5 times 2. 5 times 2 is 10. 13 minus 10, is that a 3? So our ordered pair is 2, 3. Forgive all that mess there. 2, 3. Notice, if you don't put the parentheses around it, it counts it wrong. And it doesn't really know what you've done wrong. Okay? Parentheses and parentheses. Okay? That's called substitution. You can do substitution really only if one of the variables you can isolate without having to divide. If you have to divide and get fractions, you wouldn't want to use substitution. It's a method called elimination. Just what we're going to do on the next one. Let's see. There, okay. Making it a little bigger. Solved by the elimination method. So I'm illustrating this other method, which on this one, you could do it with substitution just fine. When you're taking tests, by the way, there's no way it can force you to do substitution or elimination. You use whichever method you feel most comfortable with. Like on this one, if you want to isolate this, that first x, if you want to isolate this x and write x equals 25 minus 5y, it'll fall out real nicely. But elimination is actually the method I prefer. With elimination, you try to add the two equations vertically. Like right here, if I just add vertically, the x minus x, that subtracts out. Then the 5y plus 3y, that would be 8y. And 7 plus 25, 32. What we've just done is eliminate the x value. In order to do elimination, the coefficients need to be the same numbers but opposite signs, and you've got to have the x's and y's lined up. Like on problem number 1, those x's and y's weren't lined up. See, you got to have the x and y's lined up if you're using elimination, so that you can eliminate one of those variables. So we have 8y equals 32. Divide both sides by 8 to get y equals 32 divided by 8, 4. Now when you do elimination, to find the other variable, you're always going to use substitution. Okay, so with elimination, it's really, the instructions say solve using elimination. It's really elimination and substitution. Okay, what we've just done is found that our y value is 4. So to find the x value, plug into either one of these. I generally go with the one that has the fewest negative signs. I think I'm going to plug in right here in the first equation. X plus 5y equals 25. I plug a 4 in place of the y. So we'd have x plus 20 equals 25. Subtract 20 from both sides. And what are we getting? X equals 5? Is it 5? 25 minus 20. This is actually a very good one to illustrate the way you can check your answer. Put a 5 in for x and a 4 for y. Do you get 25? 5 plus 20, 25. What about down here? Negative 5 plus 3 times 4 is 12. Negative 5 plus 12, is that giving us a 7? Yeah. So 5, 4. Let me make it a little smaller so I can type this answer in. Parentheses. 5, comma 4, close parentheses. Okay. Well, I think I'm not going to do number 4. If you just add it vertically, notice how the 5y's subtract out. Number 5 is the one I want to illustrate. Number 5 is a really good example. Oh, let me see if I can make it a little bigger. It says solve 3x plus 4y equals negative 11. And 4x minus 3y let me try to copy it correctly. 3x plus 4y equals negative 11, and 4x minus y equals negative 2. In order, it says solve using elimination. I guess if you wanted to use substitution, you could. Which one would be the easiest variable to isolate? I'm thinking the purple y. Oh wait, you don't know what I mean by purple y? That's purple y here. Well, I'm going to use elimination, but if we just add vertically right now, one of the variables isn't going to subtract out. We need the same numbers, but with opposite signs. Like 3 times 4, if both of these numbers were 12, one positive, one negative, we could use elimination. Here, if they were both 4s, one positive, one negative, I'm thinking I'm going to eliminate the y by putting a negative 4 right here. Remember, you can always multiply an equation by any number you want other than 0. If I leave this first equation alone, so we have 3x plus 4y equals negative 11. And then if I multiply this second one by 4, by doing that, that's going to give me a negative 4 right here. So we'd have a 16x, then a minus 4y equals negative 8. I multiplied this second equation by 4 so that I'd have the same number here, but with opposite signs. Remember, if there's not a number showing as a coefficient, you assume it's a 1. That's why I multiplied this second equation by 4. Because now am I able to eliminate the y? Yeah, 4y minus 4y. The y's are gone. We have a 19x equals what? Negative 19. Divide both sides by 19. And we're going to get x equals negative 1. Okay. Plug it into any equation you want. And I think on Thursday, when me and Tim were both doing these in that class, there was debate which one would be easier to plug into. And we decided, I think it works out easiest using the number or the equation that has the fewest minus signs. So I'm going to plug into the 3x plus 4y equals negative 11. We would have 3 times negative 1, so negative 3 plus 4y equals negative 11. Solve this for y by adding 3. Negative 11 plus 3 is a negative 8. And then divide by 4 to get y equals what? It's negative 2, right? Negative 2? So you type an ordered pair. What am I going to type as my answer? Negative 1, comma, negative 2. Good. Negative 1. Oh, let me get it small enough so I can. Okay. Negative 1. Oops, I think I typed a 2. Negative 1, comma, negative 2. Close parentheses. And that's elimination. Substitution, elimination. some terminology. A matrix is a rectangular arrangement of numbers. So if we just have a rectangular arrangement of numbers, the word rows refer to the horizontal, and the word column, those are the vertical. When we discuss the size of a matrix, you go number of rows, and then you write X, but it's read by, just like if you're talking about the dimensions of a room, or 30 by 20. Okay? Number of rows by number of columns. We can take our systems of equations and write what's called an augmented matrix. Number 6, I don't know if I make it any bigger. No, it's not all going to fit. Okay. There. With an augmented matrix, see this matrix is going to have 2 rows and 3 columns. You take the system of equations and you just write in or type in the coefficients. Like this first equation, to write the augmented matrix, you type in -6, then a +9, just 9. The vertical line that's there, if you can see that vertical line, is acting like the equal sign 5. The second row of the matrix starts with a 6. Then you move over. Be careful. If you don't see a number in front of the Y, there's a negative what? 1. Okay? That's the tricky part about this particular problem. Make sure you write -1. That's the coefficient on this Y. And then the constant is a 5. This is called an augmented matrix. There's a lot of applications of these augmented matrices, but you'll see if you take a Math for Business course like Math 1324 or a finite math course out at the university, something like that. Okay? This is called an augmented matrix. Let's see. Here's another one. This is an even bigger one. Let's see. It says, write an augmented matrix for the following system of equations. I want to call out the numbers I'm going to type in, starting right there. Let's see. I'm going to make it even smaller. Let's see. So right here, you're just calling out the coefficients. Remember, if there's not a number in front of the variable, you assume it's a 1. But what about right here? Notice there's not a number, there's no x. What number do y'all think we're going to put there? 0. Okay, but the first row, it's 1, then a -2, 7 equals, the vertical line acts like the equals, -7, then a 6, a -8, a 2 equals, what number am I going to type here? 3. Now you've got to put a number. Matrices have no variables, only numbers. There's not an x, so to indicate there's no x on this third equation, you put a 0. Then what are the other three numbers I'm going to type in? 5, -5, and -1. Are y'all caught up? Well, in math, algebra, you always do it one way, then do it in reverse. That's what we're doing here. Can y'all take this matrix and write out the system of equations? It would be a 1x plus, what do I put in this box? 9. Now, be careful. It already has the minus, so minus, what number am I going to type right here? 7. And equals, is that a 4? Now the second equation, there's that 0, so notice there's no x there. You write 8y. They've already done the minus z. You see, for the minus 1z equals, what am I putting here? -5. I sure like it. I prefer these things to have the variables all lined up, but it was a sloppy programmer that wrote this problem. Notice how the x is, well, I just think it would look nicer if they were more lined up. But anyway, what number am I going to put there? 9. There's no y, because there's a 0 there. And what is this? 8, 5. A lot of very, very nice applications of these augmented matrices to production, maximization and minimization in a business environment. Our purposes, just sort of showing you what they are. And 9 could very well be the hardest problem we're doing this semester. Write the system of equations associated with the augmented matrix, and then this do not solve, that's funny. Complete the system shown below. Use the letters X, Y, Z, okay, for the first, second, third column. Okay, so like this first row here, since there's a 0 for the Y column and a 0 for the X column, this first row would just be, it's just a 1x, 0y, 0z, so just x equals 4. Keep in mind we're using x, y, z as our columns. What is this second one here? There's no x. Yeah, 1y, so just y. I think if you watch the video of Thursday's class, the question was, well, what if you typed in 1y or 1x? Does it count it right? Yeah. Like this one here, no x, no y. This number, so what am I going to type here? What letter? Z. Everyone's number 9. You're going to write X, Y, Z. That's it. It's really not the hardest problem you've done this semester. Okay. This is called an augmented matrix. And there's a way that you can take a matrix like this one and go through shuffling around and moving stuff around until it looks like this, with the ones down that diagonal. This is the preferred form of doing that, because then you have the answers. It says do not solve, but it's already solved. X equals 4, Y equals 9, Z equals 6. Okay? I would have, this is one assignment with 18 problems, I think. And there's sort of a mix. There's a little bit of substitution in it. There's elimination. This stuff here is called augmented matrices. We're through with that. And we're going to look at something called determinants now. I need to write a little stuff out for that. So there wasn't much to... Oh, wait, of the, what, that or...
Yeah, no, where it says a matrix is a
Oh,
the written out definition.
the written out. Oh, okay, I'm sorry.
You're okay.
Let me see if I can... Oh, okay. Oh, well, I need to define what the heck a determinant is. A determinant is a way of assigning a numeric value to a square matrix. We're going to look at matrices that have 2 rows and 2 columns and 2 rows with 3 columns. The determinant of a 2 by 2 matrix is, if I have 2 rows and 2 columns, that means that there are 4 numbers in them altogether, sort of like the problem I just showed on the screen that we're about to do. There's 2 rows, 2 columns, 4 numbers altogether. Here's the formula for how to find a determinant. It's A times D minus B times C. The important thing here isn't memorizing AD minus BC. It's just to note, okay, this is called crisscross that you're doing here. You're doing a little crisscross method for finding a determinant. Multiply this diagonal minus multiply the other diagonal. Make sure you always do the AD before the BC. If you go BC minus AD, you'll get it wrong every time. What I suggest is that you remember you always start with the first number. Okay? You start with the first number. I think most people would agree that this number here, A, that would be the first one, not B. Always start with the first number. Let me write down this problem. This is number 10. Determinants have properties that are very similar to absolute value bars. That's why they use these things that look like absolute value bars to denote determinants. Let's see, -7. Oh, hopefully the next one we do won't have so many 7s. I should have so many numbers for you to get the... Okay. Let me make sure I didn't miscopy it. 7, -7, 7, -6. Okay. Oops. You start with this first number. You're multiplying that way. This diagonal. The -7 times -6, that's a 42. Then this negative that I'm about to write is the one that comes from the formula. And then do the other diagonal. -7 times 7, that's a -49. Y'all see why we're getting 2 negatives there? The first minus is just from the formula. And then -7 times 7, that's giving us the -49. So be careful. The minus and negative becomes a plus. So 42 plus 49 is 91. Okay. make sure you're using what's called the main diagonal first. Okay? Always do the one that has the first number. Okay? So negative 7 times negative 6, that's positive 42. Then the minus from the from the formula. Negative 7 times 7 is negative 49. So a 91. Let me punch that in. Y'all caught up? How are we doing on time? Oh, okay. Well, there'll be another one similar to number 10 in a little bit. Okay, this one has 3 rows and 3 columns. It's going to be a little bit more involved to find the determinant for one that's this big. So let me write it down. Number 11. So I'm writing this one down. Okay. So I'm going to show y'all how to find the determinant of one that has 9 numbers, a matrix with 3 rows and 3 columns. It's a little bit more involved than for a 2 by 2 matrix. What you do to get started, it's going to seem sort of strange, you recopy the first 2 columns. Just right over here, write down those other the first 2 columns. 4, negative 5, 3, and 1, 4, 5. Now, instead of just making a simple little X like you do on the 2 by 2 ones, you're going to be multiplying a lot. You're going to have 3 of these diagonals. You multiply these 3 diagonals. Then there's a minus sign in the middle, just like with the 2 by 2. And then you multiply the other 3 diagonals. Okay? So if the numbers get really large, you might want to use a calculator. But to get started, 4 times 4 is 16 times a negative 4. 16 times negative 4, is that a negative 112? Am I doing that right? Oh, that's 16 times the negative 4, negative what? What am I doing? Let me pull up my little calculator. 16 times a negative 7 is negative 112. Okay. I did that very first diagonal. Oh, now the second diagonal, that one's easy to do in my head. 1 times 3 is just a positive 3. You see what I'm doing? I'm multiplying these 3 diagonals. The third one. 3 times negative 5 times positive 5. 5 times negative 5 is negative 25 times 3. That's a negative 75. See what I did? I multiplied each one of these 3 diagonals. Then I'll multiply the other 3 diagonals, going this way. Make sure you always start with the first number. All right, make sure you're doing this diagonal first. If you do this one first, If you don't use that first number to get started, you're going to get it wrong. 3 times 4 is 12. Times 3, 36. 4 times 1 is 4. Times 5, that's a positive 20, so I'll write plus 20. And what's the last diagonal going to be? Negative 7 times negative 5 is a positive 35. Times 1, that's just a positive 35. Then combine the 3 red numbers. The negative 112 plus 3 minus 75. Is that going to be a negative 184? Did I do that right? Negative 112 plus 3 minus 75, negative 184. We write down this green minus. It's not difficult, it's just sort of tedious, isn't it? 36 plus 20 plus 35, 91. Oops. So negative 184 minus 91, that's going to be a negative what? 200 what? Okay, negative 275. Okay, so finding these determinants, the 3 by 3 ones can be pretty tedious. Now the 2 by 2, the little ones like that, it's not that bad at all. Right? Let me punch in negative 275. Check my answer. Now, there's another one right here, number 12, and I want to show y'all how to punch it in, or how to do it using a calculator like the one I have right here. For the 2 by 2, that's pretty easy to do, but these 3 by 3 ones, all that crisscrossing, that can be so tedious. Let me show y'all what you can do if you have a calculator like this one. Let me see, can I make it any bigger or not? Ooh. Oh wait, no, wait. Oh wait, it's not enough. Okay. In order to find the determinant using a TI 83 or 84 calculator, you have to first enter the matrix. I will go second, and right up here, it's hard to see in yellow, it says matrix. And I need to actually edit a matrix, enter one, so I'm going to come over here to edit, and say enter. And the first thing you do is punch in the size of the matrix. This is a 3 by 3. By that I mean there's 3 rows and 3 columns. And these were the numbers that we were using the last time I did this in class. I should have just cleared that out so you don't even see those. But just go through entering the numbers. 9, enter, negative 2, enter, 6, enter. Notice how it's erasing the numbers that were there. 9, 4, 0, 10, 1, 0. So you enter those numbers like that, and if, this is sort of a tedious process in a way of entering it like this. So you might decide you need to watch the video once it's posted on YouTube if you forget how to do this. Say second quit to get rid of that matrix. Then you go back to matrix, second matrix, and you're going to do some math now. Move over to math, and the very first thing is DET for determinant. Say enter. But you got to tell it which matrix to use. Back to second matrix. We're using matrix A. I just always use matrix A. Okay? Enter. Enter. So the answer to number 12 is a negative 186. Being able to use it with this calculator actually makes it considerably easier, especially for very large ones, to find the matrix, the determinant of a 4x4 or 5x5 matrix. If you're a math major and years later you're doing some linear algebra, this calculator makes it a lot easier. Okay? So again, it uses that key matrix here, which on this calculator, it's in yellow, so I have to go second matrix to get to it. Okay? So for the 3x3, I suggest, especially for tests, try to do it other than doing it by hand. But if you want to do it by hand, that's okay. That's why I showed y'all the crisscross method there. Well, one more thing we're going to discuss today before we call it quits, and this ends the semester with some word problems, and we'll do those on Wednesday at the beginning of class, okay? But something called Cramer's rule. Cramer's rule is another way of doing elimination and substitution, okay? Cramer's rule is another way that you do elimination and substitution. Let me write this problem down, then I'll show y'all what Cramer's rule is. And you might think, well, wait, couldn't I just... Well, first of all, I don't think you'd want to do this with substitution. Could you easily isolate one of those variables, or would you wind up having to divide and get fractions? I'm thinking you'd wind up having to divide. So I wouldn't do substitution, but I guess elimination wouldn't be that difficult if you made both of these numbers 10, one positive 10, one negative 10. But what I'm going to do is illustrate Cramer's rule. So let me write this down. Number 13. 5x plus 7y equals 3, and 2x plus 4y equals 3. Okay. You're going to find three determinants. It's going to seem strange, but there's a pattern to this. The first thing you do is you write capital D equals, and you're just going to write down, let me get over to where I'm writing. Lift this up. You're just going to write down the four determinants, the four coefficients, 5, 7, 2, 4. And this is one of the easy determinants. You don't need a calculator for. Just make the little x would be 20. Then a minus. What's the other diagonal going to be? 14. So D is not -6, a +6. Boy, I'm messing up with my signs today, Alma. 20 minus 14 is 6. Now you're going to find two other determinants. I guess poor Cramer, he was a very famous algebraist in his day. And Tim looks on the bright side. I said the other day, I think that Cramer's probably rolling over in his grave, that this is what it's remembered for. My brother said, but just think about it. How would you feel if, hundreds of years after your death, algebra students around the nation and the world are still saying Cramer? So that's what he's remembered for. You're going to find what's called D with a subscript of X. To do that, you replace the X column. Instead of writing 5, 2, you're going to write those constants, 3, 3. Leave the X column as 7 and 4. And then just do that little crisscross. Cramer's rule isn't quite so easy to write out as, well, I'm going to state Cramer's rule in a minute. So it's 12 minus 21. 12 minus 21, is that going to be a negative 9? 12 minus 21. Now, one more. Oops, that should have been in blue. One more determinant, D, with a subscript of Y. Whatever the subscript is, that's the column that gets replaced with these constants. So in place of the Y column, I'm going to put the 3, 3, but I'll leave the X column as 5, 2. And do that little crisscross. We'd have a 15, then a minus, 15 minus 6, oops. And what are we getting for this one? 15 minus 6, that's going to be a positive 9. A positive 9. And now here's what Cramer was able to prove and what he's remembered for. If someone said state Cramer's rule, here it is, but it doesn't mean much of anything. X equals D subscript X over D, and Y equals D subscript Y over D. That's a Y right there. Poor Cramer. X is dx over d, and y is dy over d. Could y'all now write out the solutions for x equals and y equals? X dx was negative 9 over d, 6. Negative 9 over 6, it's not going to go in evenly. But we could divide both of those numbers by 3. Would it be a negative 3 over 2? And then do the same thing, well, not the same thing, but for y, it's dy over d. So 9 over 6. So a positive 3 over 2. Cramer's rule works nice when you have fractions as answers because you don't have to work with the fractions. If you were doing elimination or substitution, you would have to be substituting in the fractions, which would make it a little bit messier. Your ordered pair, x, y, am I writing too low? Negative 3 over 2, comma, 3 over 2. I will come over here, type in the answer. Make sure you put the parentheses. Negative 3 over 2, right arrow, comma, positive 3 over, oops, look, I think if I check my answer right now, it's going to say wrong, isn't it? Did y'all see what I did? Oh, they were able to figure out there was something wrong with my parentheses. Okay, good. Let me come over here. That parenthesis should be over at the end, shouldn't it? Mm-hmm. Let's do one more of these Cramer's rule problems and then call it quits for the day. We'll finish it up on Wednesday. Okay. So, let's see. Oh, this is a much better example because none of the numbers are repeated. So we have negative 3x plus 5y equals 1, and 7x plus 4y equals 29. So we're going to find d. Then we're going to find d with a subscript of x. And then we'll find d subscript y. Let me make sure I didn't miscopy it. Okay, I don't see any miscopies. Okay, you start off just writing out the 4 coefficients. That's a d. Negative 3, 5, 7, 4. We have negative 12 minus is that a 35? So D is going to give us negative 47. Okay. Now to find the ones with the subscript, whatever the subscript is, that's the column that gets replaced with constants, the 1 and 29. Like right here, the x column gets replaced with it. Over here, the y column. So I'm replacing a negative 37 with 129, and then we have a 5, 4. And we do the little crisscross. 4 minus 29 times 5, 145. Right. So what are we getting for D subscript x? Is that it's going to be negative. Negative 141? Now, replace the y column with 1 and 29. Leave the x column at negative 3 and 7. So this first diagonal. Negative 3 times 29. Is that a negative 87? Good. Then a minus. Don't help me on this next one. I can do it. 7 times 1. Is that a 7? So let's see. What are we getting here? Negative 87 minus 7. Is that a negative 94? And now, x is dx over d. So that's going to be a negative 141 over negative 47. Oh gosh, is this going to go in evenly? How about a negative, not 8, negative 141 divided by negative 47. Negative divided by negative is positive. Is that going to be a 3? 3? And then y, let me lift this up. dy over d. So that would be a negative 94 over negative 47. Negative divided by negative is positive. 94 divided by 47, is that 2? So we have the ordered pair. Oops. Ordered pair, you always write x first. 3, 2. 3, 2. And look, this assignment has a few good word problems to wrap it up with. And we'll pick up there on Thursday. If you just absolutely can't wait, I think media, well, let me see. So save this. You can't wait to see how to do those word problems. I'll work all 4 of them right here. Class lecture video part 4 word problems. Okay? So, are there any questions that you want recorded? Okay, I'll pass out some economics handouts to y'all now.